Best-in-class mining practices for managing resources of metals and minerals involve a combination of strategies and techniques to ensure sustainable extraction and use of these resources. These include the use of advanced technologies for exploration and extraction and the adoption of circular economy principles for efficient and sustainable use of resources. Additionally, mining companies are also focused on minimizing their environmental footprint through the use of green remediation techniques and the integration of renewable energy sources. The industry is also investing in advanced operations technology, managing environmental regulations, and stakeholder engagement. Our experts will present recent cases of implementation of best-in-class practices and technologies for managing mining from mine planning to post-mining remediation.
Good afternoon, everybody. Welcome to the penultimate session, MINEX. So we'll be presenting in the best-in-class practices for managing resources of metals and minerals. So notice to everybody, I'm sure, that there's been a huge shift in focus towards ESG in the most recent years. And it's now in the forefront of the guiding principles of a lot of mine operators. So they're thinking about not only the most efficient mining methods or how to get the most saleable product, but also having to think about decarbonization, ESG requirements and expectations. And that comes from financiers, from legislative requirements, local stakeholders, downstream users. So in our session today, we're going to explore technologies and strategies to ensure sustainability, low-impact mining methods, and looking at mine waste and rehabilitation and educating future generations. So I'd like to hand over, first of all, to my colleague from SRK, Chris Bray, who's going to talk about trade-off assessments and strategic planning to inform decision-making in mining.
Thank you, Mel. Good afternoon, everybody. Let me just, yes, that's all working nicely. So topic today is on the theme of trade-off assessment for strategic mine planning. This is a continuing topic. Last year in Tirana with MINEX, we were 2 years into developing these trade-off assessment tools, and we had 2 years of experience, and we'd learnt a lot, on this journey of developing trade-off tools. Probably most people in this room are familiar with trade-off studies and the purpose of it. We all do it as part of our routine sort of consulting work. However, we've taken it down a certain path to try and standardise an approach, which is we're learning from it, we're getting better at it, and we're finding that we can use this approach framework in a very similar manner from project to project, just adapt it for different processes. And it enables providing as much clarity as possible for our clients on the key decisions for their strategic plan going ahead. And the more we get into it, the more you realise how important developing using trade-off studies to develop your strategy going forward, whether that be initially looking at the economic aspects of the project, but also ensuring that you're using reasonable assumptions from an early stage, so that you're not pitching production rates too high. You're getting the right balance of applied cutoffs, which can have a significant impact on the strategy for a project, and through in undertaking this type of trade-off assessment, you're minimising the risk of surprises down the road when you get into more detailed study and assessment. So the strategic planning, which through trade-off studies that I'll just show you through, is the approach that we're using, developing, and look forward to any questions during the session or later to talk through more of the details. So the range of projects that we've worked on over the last 3 years with developing this trade-off assessment indicates that trade-off studies can be applied at any stage of mine planning. Sorry, any stage of the project cycle, from early stage exploration, preparation of early stage or more detailed PFS feasibility studies. We're finding it's becoming very important for informing exploration strategies going forward, but also for investors when they want to kick the tires on a project. We can use the same trade-off assessment approach for determining how much potential value there is there. At the same time, we talked about usually the initial focus is on the project economics, but we also find out through doing a lot of types of projects that, you know, there's other factors that are just as important, sometimes more important than just the economics in terms of waste management, what sort of volumes of mine waste, tailings waste needs to be stored on the surface versus potential for storing underground. Some of these shape the strategy for projects going forward, even overcoming some of the better economic options. At the same time, we're also looking forward to the future in starting to take into account water stewardship, planning for carbon footprint and so on. And we've found that we can expand our trade-off approach and tools to take these into consideration. This gives a bit of a roadmap of when we started going through developing this specific trade-off assessment approach was back in sort of late 2020 when, after many years of doing trade-off assessments, and even these taking place in very detailed feasibility study levels, we recognise that when you're at a detailed level of study, it becomes very time-consuming and very costly for a client to do this sort of trade-off assessment, strategic analysis. So the motivation was really, why can't we build tools to be able to undertake the trade-off assessment and assist with strategic planning decisions much earlier in the process? So we started off with, we didn't realise there were going to be what we call first generation models now, but it was just bringing everything together in a single spreadsheet analysis tool with all the components feeding in. And what we call first generation models now were concept level. They were based on average grades per scenario that we're looking at for the range of cutoffs, production rates, etc. And as we started building up more and more projects, we thought, well, why don't we expand these trade-off models into more detail? And it evolved into what we call now the second generation models, which are almost looking at a pre-feasibility level of detail, but keeping in mind that it's still at a scoping level of accuracy. So, you know, it's based on as much data as available at the time for the project and getting the most out of it to help with that strategic decision-making process. And you can see the range of projects that over a range of countries, a range of commodities, many different variations of restarting historic mines, greenfields projects getting off the ground, applying it to operating mines for putting together life of mine plans for reserve estimates. And it's really quite an adaptable approach, which is getting more and more powerful the more we develop it, and the more projects that we have under our belt to see if we can adapt it for the next one. And so far so good. At the same time, we still use both the first and second generation models. They both have their application, just depending on the requirements of what the client needs. So this just tries to show as simply as possible the schematics of the process that we go to. So this is the basic framework approach that we use, and the flow of the mine planning processes external to the trade-off model, and how they feed into the trade-off model itself to get the full sort of picture of economic results. At the start of the process, typically we're doing some calculations around a NSR value or a cut-off grade approach that's incorporated into the resource model. From the resource model, we're running as many scenarios as we need to with underground stope optimizers or open pit optimization tools to build up all those scenarios, raw data, that inform the trade-off model. So all that raw information has been developed in the background, feeds into the trade-off model, and from there, that's when you start understanding the strengths and weaknesses of the project from a production rate, potential, how does it behave for cut-off grades, and we can, a lot of the time we're incorporating multiple mines, multiple zones within a mine, and just trying to map out what is the best, where's the most value, so what makes the most sense from a sequencing point of view, from a production rate point of view, and it's like pieces of a jigsaw puzzle coming together to form results for each of the scenarios on a like-for-like basis to help the client understand what they're dealing with. This is one part of the process. Some of the scenarios that we look at, we're looking at a range of minimum stope sizes, which will, impact the mining method approach, have an impact on the dilution that's included. Obviously, the bigger you can make your stopes, the cheaper it'll be to mine, but then you're introducing more dilution and so on. As an example, we're looking at a range of cut-offs. We don't just look at single operating cut-offs, we look at a whole range of cut-offs, and through the economic analysis approach, all of these scenarios are taking into account capital as well, which is usually a missing factor with some of the trade-off approaches that are not as comprehensive there. And with respect to applying a range of cut-offs, we're seeing how it behaves with higher grades coming into the model but a reduced mining inventory. Just as importantly, we're testing out how robust each of the mines or resources are in terms of production rate. There are rules of thumb which guide us as to how much production can you get out of a deposit. But we also find, assessing a full range of production rates, a bigger production rate is not always better for the project. So it's trying to find the right balance, and let's say not selecting a production rate that's too high that we find when we go into detailed planning cannot be achieved in the mine plan. So we're just trying to find that balance, and if anything, just rule out options which shouldn't be considered going forward, which is helpful for clients. Within the spreadsheet trade-off models that we develop, we want to make it as simple as possible. So within the trade-off model, it has auto-scheduling functionality, and it gives a lot of flexibility to play at a spreadsheet level on range of production rates, and that will flow through into the sequence of mining each of the mines, the grade profile that comes at a level of accuracy, mining level of accuracy there. So it's about as much as you can squeeze out of a project within a simplistic mine planning trade-off model. This just shows an example of the typical sort of economic and physical results. You can show them for a range of production rates, for a range of cut-off values, and you could get great visibility in understanding how the resource behaves, how each mine behaves, or combination of mines behave when you over a range of production rates, cut-off values, etc. And it really helps with the decision-making process for the strategic plan going ahead. Just as importantly, we talked about the project economics, but even more important these days is waste drives a lot of the time what the mine strategy is going to be, particularly in sensitive areas where there's not a lot of real estate to store mine waste or tailings on the surface. And so as part of assessing the different options, we're able to determine, for different combinations of open pit and underground only, what sort of waste are we going to be left with at the end of the mine life? And that's an important factor to take into account in the strategic mine plan going forward. So basically, this is generally what we're trying to test out here. What mining methods make the most sense? How does the resource or number of mines behave when you're over a range of cut-off values and production rates, and economically taking into account the capital costs as well as the operating costs that come along with that. These days we're branching more into estimating the emissions and carbon footprint that's coming out of the mine plan. We would say using this approach, the limitations are that you do base it on average grades, but usually really at early stage planning you don't want to push that level of detail much further than what we do until you go into more detailed underground planning. It serves its purpose, and that's what it's there for, just to help with the strategic approach. So in conclusion, strategic planning, you can apply it at any stage of a mine, whether it's a new greenfields exploration project. It can help focus on what your future drilling might need to be to prove up a sufficient resource or upgrade a resource for detailed mine planning. Current clients are finding that is very important to them in making decisions in a difficult investment environment and raising money. So the project setting will have a significant influence on the major options to be considered and constraints, whether you've got it's very isolated or you're in a mountainous topography. Typically the main options that we're trying to nail down or narrow down before going into more detailed studies around the mining method approaches to use, combinations of open pit, underground. We can compare the processing approaches and the waste products that come out of that, materials handling approaches, and more we're sort of building in environmental and social impacts, which are shaping a lot of the strategies for companies going forward as well. It's extremely important. So this phased approach can greatly assist in reducing the options. It is at a sort of detailed but scoping level, but we've got 10 projects under our belt now, and the more you do it, you realise that companies that don't take a similar type approach are they're probably moving quickly ahead without being informed what the outcomes are going to be, and they're probably going to get more surprises in a bad way when they get into more detailed planning. So that's where our focus is. That's where we're continuing to learn and develop, and it's very interesting for us. So thank you for the opportunity to share that.
Thank you, Chris. Good job. That's actually
Any questions, Mel?
Yes, really refreshing to hear you guys saying that the waste management is just as important as the economics. It's really good. I have got a question, but I'd like to just give the opportunity to the audience if there's anybody in the audience that'd like to ask Chris a question. I'm going to go. How important, just on the back of what I just said, how important is ESG in trade-off assessments?
Well, I guess, say 10 years ago, it wasn't at the front of planning, but whether we like it or not, we do like the technical challenge. We're being forced into consider greener technologies, battery electric equipment, and very much focused on carbon reduction. Mostly thanks to CEO who've made a lot of promises going forward. So that's actually good for us in that, we're on that path of helping them understand what their carbon footprint is and looking for practical solutions for reducing that. And one of the ways is through these type of trade-off studies to help them make the decision on which way they want to go in the future. Sorry, I'm not sure if I should be facing this way or to Mel.
It's fine. Thanks again, Chris. That's great. Thank you.
Thank
I'd like to welcome our next speaker, Ian Pickard from Strategia Worldwide, who's going to talk about monitoring tailings and tailings risk assessments.
Right, thanks Mel. So a bit of a natural segue actually, having spoken about tailings management as part of the mine plan. I want to talk about a pilot project we've been running with Celebello Resources in South Africa. Been running for 18 months now to sort of prove the concept around an integrated approach to risk assessment and 24/7 monitoring. Tailings Protect, I should say, is a consortium led by my own company. The geotechnical and ESG risk piece in this occasion was done by WSP, I think are in the room somewhere. The monitoring technology by Insight Terra, a South African-based company who was spun out of Inmarsat. If people are familiar with Inmarsat, who spent literally millions developing the technology. And the insurance side, we work with McGill Partners, who are a broker in the London market. You can see there the facility we're talking about. It's Johannesburg Platinum Mine, part of the Celebello Group, in the Rustenburg, the western arm of the Rustenburg Platinum Belt, west of Johannesburg. What's behind it is the global industry standard on tailings management, which I'm quite sure everybody in the room is familiar with, that came about in the wake of San Marco, Brumadinho, and those catastrophic tailings storage failures. And our aim is to provide an integrated, real-time tailings monitoring and risk management solution. So companies can comply with GRSTM, meet the regulatory requirements, and also provide assurance to insurers who are increasingly leery of tailings risk. And we know some case studies where miners have tailings risk written out of some of their key policies. There's three key elements to it. I'll drill into each one a little bit more. But first of all is the independent validation. And I stress the word independence, and we can look at that more. But essentially it's doing an independent gap analysis against the standard or any other accepted standard, such as the Canadian standard. The monitoring piece, which has got subcomponents of designing it, which can be informed by the risk analysis, putting the monitoring in place, if it's not there already, the data transformation into a cloud-based platform, which is the key, and creating the dashboard. And then last but not least, using that information to take to insurance markets if you want to. You don't have to do all three elements. Some companies don't want the validate. They think they've got their independent assessment, they want the monitoring. We've even had instances of not wanting the monitoring but want the validation. But to get the insurance piece, you really do need to do the whole thing. The validate piece, first of all, it's a gap analysis, involves an information review, a technical review, and a risk classification. And when I say independent, that's quite an important word, because if you drill into the ICMM conformance protocols for the standard, it's very clear that the resident engineer record is not deemed to be independent because they're already working on it. They may well have designed it. And similarly, if you have a tailing review panel board in the company, that doesn't count. So it needs to be a third party. And there are only so many people who can do this, so it might be that one company is the EOR and another company has to do the validation. But the output looks like that. It's a sort of color-coded chart and an action plan of what you need to do to close the gaps. And it's a fairly comprehensive process. The heart of it is the monitoring. And first of all, you need the data collection sources, and what you need will be determined by the risk assessment. Or it may be mine's got them in place already, but they're not hooked up to anything. Or in the case of this particular project, they had some piezometers in place, but not much more. They can be in-the-ground sensors. If satellite monitoring is more appropriate, that can be fed into the system. It's whatever is most appropriate. What I would say, however, is you can't monitor a tailings facility by satellite alone, or only very rarely, because you're not going to get 24/7. It only goes over every 12 hours. Can't work through vegetation, and won't measure things like phreatic levels inside a dam. The data is ingested into the automation system. It's transmitted. It can be through 4G or terrestrial connectivity, or in very remote areas, you can use the satellite system. And because of the relationship with Inmarsat, we can access their systems, although that is a lot more expensive. The smart bit is the management, storage, and processing, and inputting into a customizable dashboard. So this will give you the information that the client wants, and it can be different on every case. Although if they've got a portfolio of dams, you probably want some consistency about what information you're looking at and in what format. And then the key point here is that information can be shared by to third parties, your regulator, your communities, your insurers, whoever you want to share it with, but it's the company's data. So you can release whatever you want to release into another forum. And APIs can be built so that can be shown on apps and other systems. This is a snapshot of a dashboard. I'd give you a live feed, but the technology here can't cope. But I'll be very happy to show you on my laptop the status of this mine right now. And you can see on that one, all the sensors are green. In fact, actually, one of them is yellow because a cable's been broken. But this is real time, 24/7, and it will measure whatever needs measuring. In this case, we're looking at phreatic levels inside the dam, so the water level inside the dam, milled tons, slurry density, tow drains, freeboard metrics, return water flows, and rainfall. When we started the project, they had 6 piezometers. And over the last 18 months, they built out that suite of monitors. So that can be presented now as a thoroughly well-managed and understood risk, with alarms built in that react to if something happens, such as this cable being broken. Data belongs to the company, and it can be sliced and diced and shared as required, as I said. This is just another snapshot, and this is a feature of it, where you can have a cross-section. So you can see there, surface of the dam, the trigger phreatic surface in yellow, and where it is when the snapshot was taken, and the sensors, or the line of sensors, the piezometers picking up the phreatic level within the facility. So if it gets to the orange, you have an alarm, and you can do something about it. The governance has to be in place, because at Brumadinho, they did have alarms. They went off, and no one did anything about it. So, you know, you can't compensate for that level of poor governance. But if everybody in the company's bought into it, as our client is here, they live and breathe this. And if something goes off, they react very quickly. So that's what we call line B, and there's about 4 lines of these across the dam at key points. That's the milled tons. I'm not going to let you go into the detail, but you can see that, you know, there's a readout there of what's being produced. There are the tow drains, the leakage from the back of the bottom of the dam, and the green indicates the status of that particular sensor. And if something goes wrong, it goes amber and ultimately red, and you can interrogate each sensor, and then you get the data you see on the right, which will give you the detailed data of what's happening. Last but not least, the insurance piece. It has a journaling function, which can be used to produce a data story, which can be shared with the company's broker, who will share it with their insurers. And you will find that, as I say, insurers are getting leery of this risk, and a very good example is directors and officers insurance. Those who are not familiar with it, it's the insurance you take out to protect your directors against any liability. And to have a tailings exclusion in that will make it very hard to hire a non-executive director, because no one will take that risk on. So this is really important. And as the Global Standard Institute comes into force, which is happening this year, I understand, the big 5-6 mining insurers who write 80% of the risk across the industry have all said they're not going to provide insurance for people that can't demonstrate they're compliant with the standard. Well, here's how to demonstrate compliance. our connections, we have good connections to the insurance markets, our connections tell us that showing a good risk will result in better terms and pricing. They may even contribute to the cost. It's a well-established practice in the insurance industry. And what we give insurers is a 5 to 10 page document with the key information I've bulleted there, which is very different from the current practice, which is a telephone book produced once a year. And they have to leaf through this and try and make sense of it. So we're packaging it in the information in the format that they need it. And it's comment on monitoring system, the trigger action response plan. The alarms have gone off, we've done this. It also has the action plan that came out of the risk validation to say, well, this is what we've done, this is what we're going to do. And another key point is that the current engineer record may well not be covering ESG risk. In fact, their geotechnical report, they won't. ESG risks have to be included to comply with the standard, and this includes ESG risk. Quick overview of the progress to date. So phase one started, I say, July 21. We did the gap analysis. We onboarded the existing monitors. And since then, we've been putting in new monitors in place and ingesting further data, which is what you saw on the list. So this is a now mature, established, and working system. And I would say we've had a bit of pushback from some companies saying we're going to do this ourselves. Great. However, it's going to cost you a lot more money and take you an awful lot longer than you think it's going to. It's complex technology, and pulling all the pieces together is not a simple operation. There we are. Very happy to run a live demo for anybody that's interested. Otherwise, give us a call. That's me there. Thank you.
Great, thank you, Ian. I think it's really good to put the GISTM into the forefront of our minds again. Again, has anybody on the floor got any questions for Ian? Oh, sorry, I thought it was someone stepping forward. Can I ask a question then, Ian? You talked about the satellite monitoring and the in-situ monitoring. Can you just elaborate a little bit more on that as to, like, in what circumstances you would choose one or the other?
Yes, absolutely. It depends entirely on the risk profile of the facility. And it's not just the facility, it can be the downstream ESG risks. So, for example, in this case, we've got the facility itself very well monitored. There are downstream communities. And at the moment, then, if God forbid something happened, they're not in the flow path of any escape. However, if those communities were to change, that could be a different story. So there's a great use for satellite monitoring. Map where it is at the moment, put a geofence around it, and if it starts growing into the flood path, an alarm can go off. And we haven't done that here yet, but that could be a subsequent. We've discussed it. That could be a subsequent use. But the point is, it's whatever is appropriate, and every facility is different. And some will have risk of liquefaction, some will have more risk of slope slippage, or whatever.
Great. Okay, thank you very much.
Thank you.
I'd like to welcome our next speaker to the floor. He's Christoph Wolaka from KGHM Cuprum Research. And Christoph is going to talk about using underground excavations for research and education.
Well, thank you for the introduction. Good afternoon, everyone. My name is Christoph Wolaka. I am assistant professor in rock engineering department of KGHM Cuprum. And today, very briefly, I would like to show you some possibilities of further use of underground workings, not especially for the mining purposes. So maybe at the beginning, few words of introduction. In this slide, you can see the statistics prepared by Eurostat, which show us the potential job losses in coal mining industry until 2030. As you can see, in general, in Europe, we can expect about hundreds of thousands of job losses during the energy transition, and this is natural. We need to do that. But the problem is that we don't need to face this issue only in future, but we also have this issue now, because Only between 2014 and 2017, we closed over 27 underground mines in Europe. So this is quite problematic for local government, local authorities, because we need to find something new for the local communities. In Poland, we have some quite bad example of not very well planned transition of mining, of closure of mining activities. And here you can see the example of Flower Fields and Coal Basin, where we closed the coal mines from year to year, and in 6 years, so 5 years from 1997 and 2002, the unemployment rate increased in the region from 15% up to 32%. We can also look at the jobs in the underground mining in coal mines, and as you can see, in 1980 there were over 148,000 of workers in our coal mines, but in 1996 there was also 70,000, so half of it. So the question is, what can we do to really minimize or prevent the negative effects of the termination of coal mining? And of course, there are some possibilities of using, once again, these underground workings. And here you can see some examples. For example, in Poland, the very popular way is to make underground touristic roads, so we can make some attraction for local communities. At the moment in Poland, we have over 200 of touristic roads, underground touristic roads, and employment in this sector is about 1,500, so not much in comparison to the underground coal mining, but still it is something. But what is important also is the fact that present EU general trends allow us to use underground workings for different purposes as well, not only for tourism. So we can use this site for development of new, more efficient mining technologies. We can use this site for conduct physics and astrophysics measurements, food production, energy storage, education, and R&D. So because of very unique environment, this is very attractive place for do any kind of scientific work. And we saw this problem already in 2016 when we started preparation of the pursuing project. And between the years 2017 and 2021, we were involved in the pursuing and EOL project, which were related to the development of underground laboratories in Baltic Sea region. In general, with help of University of Oulu, we developed the business models or most suitable way for using of underground workers. We identified key partners which could be interested in using these underground sites. We analyzed the revenue streams, and in general, any kind of repurposing of underground workings could be profitable if we overtake all challenges related to it. As you can see here, in general, the most interested facilities or entities will be universities and R&D centers, because they can conduct many different types of research in these sites. Considering the revenue streams, because this is also a problem during the closure of the mine, how we can maintain these facilities, this is quite problematic because of the ventilation, lighting, and hazard mitigation. So in general, the best way is to start thinking about it before actual termination of underground mine, and try to get some EU funds and commercial projects. And I will show you some example of such way of repurposing of underground mines. So this is this example, one of two examples, Kaliolab. So here you can see the Pyhäsalmi mine in Pyhäjärvi region in Finland. In general, this mine was expected to be closed in the next few years, already in 2015. So Finnish government think, what can we do to provide further jobs for local community? And they decided that because of good environmental condition in this mine, that they will try to open underground laboratories there, but not only one underground laboratory or touristic road, but many of them. And at the moment, they perform a lot of research related to the education and training, mining and tunneling, mine reuse, geothermal energy, food production as well. At the moment, they have also, I believe, the contract with European Space Agency, because they want to have some place to test their technologies in very harsh environment, simulating the environment in space. So they have a lot of things to do after the termination of excavation. And at the moment, they opened 7 underground laboratories. So constantly conduct measurements, astrophysical measurements, physical measurements. They have the chamber for food production. And they also have the deepest sauna in Europe at the depth of 1,400 meters below the ground surface. So they do a lot to maintain this facility after termination of mining works. And what is also important is the fact that this is very interesting for a scientific community. From 2015, they gather more than 10 big international EU projects, and most of them were led by the University of Oulu, which is leading the Kallio lab. So they have, at the moment, possibility of earning money and giving job to the people. And also, R&D centers just go to them and try to set up new activities for commercial use. So this is very good example of such good repurposing of underground mining. And this is the second example, Rajsiezese mine, which is led by University of Freiburg, not far away from Wrocław. And they also changed the underground silver mine into the research area. So they conduct the big international, big EU projects, big German founded projects related to the development of new, more efficient and more safe mining technologies. Of course, this is also used for education because this is the facility which is managed by university, and there is also part of tourism. So they, for years, generate some quite significant incomes only with maintaining of these underground facilities. So we know that there are possibilities, but of course there are also challenges related to the use of these workings. And we try to identify these challenges. So we want to know why stakeholders don't want to go underground, because not everybody wants to start working there or invest their money into underground facility. And we collected the data from underground operators in Baltic Sea regions. We also collected the data from local universities and mining operators like KGHM, and try to identify the risk related to the such activities. And in general, as we can expect, the biggest problem for stakeholders which are not familiar with mining activities is the safety issues, So because of this lack of lighting, lack of ventilation, water problems, sometimes seismic activity, people are not aware how we can prevent it, and sometimes they don't want to invest in such facilities. Another problem are the legal obstacles, because in the most of EU countries, any kind of activity underground must be followed by local mining law, which is very restricted in most cases. So, for example, in Poland, we have the experimental mine Barbala. This is the underground laboratory. Only if you work at depth about 2 levels, 30 meters and about 70 meters, maybe I am wrong, but in general, not very depth. But they still need to fulfill requirements of mining law. So this is very challenging for small facilities. Of course, big investment costs, but we know that if we plan this before actual termination of mine, we can minimize this negative effect. And of course, besides the rest of challenges, we focus on the risks, because we would like to provide some guidance for people who would like to start these underground activities. And we prepared the list and the method for qualitative evaluation of risk. This is the preliminary risk for underground laboratories. And these documents can be found on the UL website. And in general, after these 5 years of project, we decided that this is the topic which needs to be further developed, and in 2021 we set up the European Underground Laboratories Association, and we are trying to promote science, research and technical development in underground facilities. At the moment we have 5 underground laboratories from Baltic Sea region in our association, and over 10 partners related to R&D, universities from Poland, Finland, Germany, Switzerland. So we have expertise to help you to develop your concepts and activities in underground condition. Here you can see our laboratories from our association. As I said, at the moment we have 5 laboratories which already joined our association. There were 7, but 2 of them were from Russia. So during actual situation, we need to terminate their participation. And from my side, this is all. If you have any questions or consider starting a new project or have idea but don't have access to the underground facilities, you can contact us. We will try to find out some solution. Thank you very much.
Very good. Thank you very much. Some of that blew my mind, like the underground food. That's crazy. Could just ask if there's any questions for Christoph from the audience? Questions that everybody's asleep after lunch today. It was really interesting for you to really highlight the unemployment factors with the mine closure as well, because I must admit my first thing when I think of mine closure is how you're going to rehabilitate the land and how you're going to leave it from an environmental perspective. So yeah, thanks for highlighting that point to us as well. Could you just elaborate a little bit more on the laboratories? And one direct question I had was, like, who takes responsibility for the safety, and is somebody doing like checks on geotechnics, etc.?
In general, if we conduct new projects, for example, as we did in Pyhäsalmi mine, we were responsible for geomechanical analysis and general geotechnics in underground. So we are responsible for providing safety, but other partners, like for example, University of Oulu, are experienced in preparation of business models. So we have different parts which are responsible for different things in this association. Great,
okay. And yeah, I'd maybe grab you afterwards, but I'm really interested to learn more on the space lab and the food lab. That's fascinating.
Space lab, yeah?
Yeah.
So there is a very interesting topic because, we try to send something to space, but we would like to test it before. And as far as I know, Kallio Lab has some contract with European Space Agency because they would like to use this very harsh environment to validate their results. There are problems with connection in underground, lightning, these things make that it is more difficult than on the surface. Yeah. So they would like to test it. Yeah.
Great. That's great. It's very interesting. Thank you very much.
Thanks you very much.
Christoph. Okay, we'll move on to our next speaker, who's my colleague from SRK, Iñaki Garcia, who's going to talk about innovative techniques to enhance geotechnical design processes.
Thanks, Mel, and thank you everyone for being here. Let's hope we don't fall asleep now after lunch. It's good to keep everyone engaged as much as possible. I'm going to talk about 2 things here. First thing is machine learning and how we can apply it to geotechnics to make sure we get the most value out of our expensive drill holes when doing PFS and FS studies. So this is the typical density of drill holes you might get on a PFS or an FS study. That's a regular pit shell. And this is what we geotechs have to work with and design the pit shells, the slope angles with. So as you can see, it's not much. These holes are usually logged with RMR or Q or some specific geotechnical system, which of course is very useful to us. And unfortunately, the rest of the drill holes are, if we're lucky, they will get some RQD. But that's basically it. We have core photos, which are useful in telling us maybe core breakage or where we have poor ground conditions. But as you can imagine, going through all those core photos one by one is kind of tedious and very much time consuming. So we don't do it. We rely on whatever the geologists tell us from lithology, faults, etc. But can we do better than this? How can we maximize the value of all of those expensive drill holes we have from resource drilling for geotech? And why am I posing this question? Because basically, if we have more, as a geotech, have more information on the geology, then I can be more aggressive in my design because I have less uncertainty. So I assume most of you are mining engineers, so you are on the receiving end of when we geotech people design these slope angles. And the questions that I always get is, can we make this a bit steeper? And well, the answer is, well, if I knew more, I could tell you whether yes or no. But as of now, this is the uncertainty we work with, so we need to design for that, or cater for that. And so, well, we're talking about machine learning. Why not train a computer to automatically lock the core, to give me the RQD or give me the fracture frequency from something, from the core photos? Well, there's a couple of challenges there. The first is, what always happens in this case is that you need to be able to identify or differentiate between natural and artificial breaks in the core, and that is very subjective. I mean, that is even challenging for practitioners to do in the field, you know, looking at the core. Imagine trying to do that with core photos. And then also these measurements, RQD, fracture frequency, they rely on interval lengths. And so that implies a certain smearing out or averaging of properties along an interval, which is also subjective in its definition. And by definition, it is low resolution. So you're talking about 3 meters, 2 meter intervals. And so if all of this is very subjective and depends on who is doing the logging on site, imagine trying to train a computer to do it for you based only on core photos. It's quite daunting, to say the least. So, okay, let's talk a bit about RQD then, because RQD has also some problems in that you see on those drill holes there's a couple of red areas that is RQD close to 0. That means very broken ground. But so it can be very bad news for us, right? We see a lot of lots of those red and brown areas there, and we think, okay, that's lots of bad ground. We're going to have to design very shallow slope angles. But we don't know actually, because of the way RQD works. We don't know if we're looking at basically gouge, or we're looking at just some broken rock, or if it's mechanical breakage due to drilling. So it depends on the context. We need to look at the core photos manually or have some other metrics to make sure that we are, in fact, dealing with bad ground. Another thing with RQD is that, as you may know as well, it is usually poorly logged. And so when people on site or geologists, they log every single fracture that underestimates RQD. And so that means that the parameters are worse, so the slope design will be even more conservative than it should be. So yeah, RQD has a couple problems. So we're trying to move away from that and define something that we can measure and that a computer can interpret quite objectively, which is this core damage index. So you can see there a couple of pictures of typical core breakage or ground conditions in the core, rated from 1 to 6. And so these are solely based on the class size. So if the pieces of core are more than twice the diameter, then you have class 1, and so it goes till class 6, which is gouge or disintegrated ground. And the good thing about this is that the computer can identify this. It's high resolution, and it uses core photos, which are readily or usually readily available and abundant. And so now, if we move forward and we look at that red interval of 0 RQD, then it turns out that most of that was just okay ground, green, yellow, blue, whatever. And then there's only a couple of sections which are really, really bad ground, which is this red or class 6 ground. So that's what this machine learning algorithm has identified, and that is, yeah, that is effectively bad ground, probably a fault or something that we need to design around. Another example of how this can be used. So there is a fault zone that was identified in one of our projects, just lining up all of those red areas. We found that there was a fault zone with varying degrees of gouge and ground conditions. And so the power of this is to leverage all of those core photos that we have, that we always have usually, to get more information and to improve our designs. Going to move on to the next topic now, which is how can we automate our geotechnical design for underground. So, as you may know, the design procedure for underground geotech is iterative. It's quite unique in that it's one of these cycles for each layout. And it's also always a back and forth process with the mining engineers. So the first thing that happens is that the mining method gets defined. Then we need to define the size of stopes, pillars, panels, whatever. We need to calculate the stresses somehow, 3D stresses, 2D stresses, whatever. Compare them with the suitable failure criterion, and then if things go well, then we can optimize the design or leave it as it is. And if stresses don't comply with the strength criterion, we need to change its geometry. And because this is a change in geometry, it tends to be a very tedious process and slow as well. So when you are on the receiving end of our geotechnical designs and you wonder why we take so long to design this or that, it's because of this issue here. So how can we streamline this? So a bit of a spoiler here, it's by automating this process. So we can use many softwares to analyze the 3D stresses or the 2D stresses. In this case, I chose FLAC3D because it is customizable and programmable, so you can tell it what to do in a routine and run that routine interactively. And then Python as a backend of all of that, just to cycle through this loop. It tends to be a loop, so it's good to have Python to cycle through that. Any other coding language can be used as well. So I'm just going to show an example of a room and pillar design here. We have our main decline there down the middle, and as you may notice, something is missing. We need some barrier pillars here around the decline. So how do we find the size of those? Okay, we can sort of eyeball it, but we need to verify this to make sure it works. We're going to calculate the stresses there. How do we do it? We do a cross-section. So we have our panel, barrier pillar, our decline, the other barrier pillar, and then the other panel on the other side. So that's kind of our layout. We can put this into software. In this case, it's a very simple 2D software where basically you draw these shapes. You analyze the stresses. You get the stresses in the barrier pillars. You get the average stress, 20 MPa. Pillar strength, 18 MPa. Too bad. We need to make it a bit wider or something. But the issue is, okay, what if you have this layout and all of these other layouts to analyze as well? You need to iterate with each one of them. And then you have different heights that you need to analyze as well. And then you have different depth ranges from 100 meters to 600 meters. So you need to do all of this iterative process for each one of these, and then send to the mining engineers. They will get back some changes. You need to do this all over again. It's quite tedious, time-consuming, and expensive. So what we do in this case, we use FLAC3D, as I mentioned. I will do all of these stress analyses quite well. It will take a bit longer than other softwares, but it'll be worth it because it's automated, basically. So we've turned that tedious flow sheet into this one here. So there's a Python code that runs as a backend, as I said. And what it does, it tells what FLAC3D should do. FLAC3D will generate the geometry automatically based on those parameters, get the stresses, and then Python will do the verification, and if necessary, well, make it wider, we'll modify the geometry, or it will optimize it if it can be optimized. And then the nice thing is as well, Python can collate all of these results into a table. It goes straight into the port, or straight into the email, or straight into the communication that we use for our clients. So, sorry, forget another example here. I still have time. This can also be used for the other mining methods. We use it as well for the Evoca mining method. We had to design some pillars that were just between the muck pile and the backfill. There's this unsupported pillar here. So what we use is we use Slack as well to simulate all the sequence, and then do all of this process again, and give us the results that we need without much manual input on our part. Okay, that's all. Thank you so much for your attention.
Thank you, Iñaki. I feel your pain on the lack of core. As a geochemist, we also are looking to characterize the waste, and you have all the drill core where the ore is, and obviously none where the waste is. So yeah. I feel your pain on that one. Okay, I'd like to again welcome any questions from the floor for Iñaki. If you'd like to step forward. No? Okay. Could you elaborate a little bit? You said obviously you're inundated with core photos. Is there like, do they have to have a set criteria for a core photo to be usable for you?
Well, yeah, at the moment there is a bit of a constraint on that. We need to have photos that have all the same format and roughly the same orientation. They cannot be very skewed or anything. And they have to have a naming with the depth and everything. So the metadata has to be in the name of the file. We're trying at the moment to get that box number and depth and a borehole number from the photos themselves. But of course, as they are usually handwritten, it's very challenging to train a computer to read that. But we are working on it. At the moment, they need to be kind of standardized, yeah.
Can't just take one on your phone and be
Oh, no, yeah. It has to be a bit better than that, yeah. Hopefully in the future, yeah.
Good stuff. Yeah, please do.
Sorry, Iñaki, just a question. Like, how widely accepted, or how easy is it to sort of use these automated machine learning practices on real projects these days? Clients open to using it? Is it easy enough to apply to new projects?
Well, yeah, I mean, they require a bit of training, but I think the good thing about, I didn't mention this, the good thing about these objective measurements on core that rely on this class size based on the diameter is that you can port this to other projects without the need of much additional training. And as for the clients themselves, it is, yeah, they are quite okay with this, but of course it needs to be verified. This training implies a bit of verification to make sure that the computer model is working as expected, yeah.
Thank you.
No worries.
Okay, thanks very much, Iñaki. And I'd like to welcome to the floor our next speaker, Lasse Moilanen. Sorry if I pronounced that wrong. The CEO from Mining Finland, and Lasse's going to talk to us about Finnish technology, services and education.
Thank you very much. Good afternoon all. Like Mel said, that I'm Lasse Moilanen, and I've been now working 1 year as CEO in Mining Finland. So there is, let's say, a little bit of info what we are doing in our 5.5 million people country. That it is what is Mining Finland. That basically we are promoting Finnish mining technologies and services. So we have 78 members who are actively selling services. Technologies, education, export to global mining industry, and there is, let's say, our main role is to help our technology providers find new cooperation partners globally, and then there's of course one role is also to working as helping to get foreign investments to our projects. So we have mining projects as members, and also some mining companies who are looking for investors, so that is also one role in our team, and also we are facilitating R&D and education cooperation between global mining sector and our members. So it is basically, someone said that when there is some euros going in or out from our border, that there is somehow Mining Finland is involved. So. Yeah, we have now 78 members in Mining Finland, and we are covering quite well all of our mining value chain in Finland. That from exploration until the battery chemicals, we have good members, and we can offer a whole range of solutions for all value chain of mining. And there is, let's say, from startup companies to large companies, and that is also benefit that there is some large companies who are making some, solving some bottlenecks with some smaller startup companies together, and that is very active cooperation with our member teams. So then it's, of course, there is some private technology and service companies in our team, and some, let's say, junior mining companies, universities like Oulu University was mentioned earlier, and some research organizations like our flagship Geological Survey of Finland and VTT and some others. So it is, there's a lot of active members in our team. And we are also globally very active in BDAC and Mining Indaba and many other events. And of course, thanks to Anna and many others here, that we are also could join here as a MINEX. There's actually also one picture what is about one small technology provider from Finland, that there is, I have some drones for exploration, and they are quite unique in that area for how exact are those measurements which they have. Actually, there is, of course, a lot to say about the Finnish technologies, but now I was focusing on circular economy solutions, that there is quite a lot of new innovations in that area that which have been coming to market during last years. So it is, of course, there is one picture made by our government that there was, let's say, our government made survey what kind of wastes we have in Finland, and based on that survey, there was said that there is 76% of our waste is coming from mining industry, and basically that is calculating all of side rocks and all the tailings and all the others. So there is, let's say, of course, huge potential for new innovations in tailing area and side rock area. Then it is, of course, thinking about what kind of new raw material opportunities there is in basically from for mining companies, what kind of possibilities there is for, let's say, for some commercial ones, and then, let's say, how much we can reduce consumption of natural resources with right kind of circular economy solutions. And of course, one is also like how we can minimize the energy consumption. Some examples what we are doing in Finland, that there is, of course, I'm proud to say that there is about 90% of, let's say, waters in mining is now on circulation, and there is some mines like Sotkamo Silver, the biggest silver mine in Europe, that it's almost totally circulating their water, so it's quite deeply in circular water circularities, and there is, of course, then still 10% to circulate, so there is not a lot of new innovative companies who are doing some work with solving those rest of 10%. And there is, let's say, promising stories later on that which could be the solution for those. And of course, the recovery of excess energy is one of the key role in the circular economy sides. Then there is thinking about side streams, that there is good raw material solutions for cement and concrete production. Like there is companies like Betolar who could be good to check for investors in future, that what will happen in their area, that they have a very clever solutions for cement and concrete production, and there is also quite many others who are collecting the raw materials from tailings. So it's quite a clever idea to use the tailings in cement and concrete industry. And then, of course, there's up to 90% of materials used in steel industry is coming from recycled. That basically Outokumpu stainless steel production is using more than 90% of the recycled steel in their production, and thanks to that they have a very low carbon footprint. Then, of course, some innovators in the mine. That, of course, you have met Balsatec and GTK here that it is a lot of innovative solutions for both of them, but there is still some others, and I picked few of quite exotic ones to hear that. One is Otamäki Mine Oy, that it is, let's say, this mine is a closed mine. Earlier it was iron and vanadium located near from Kajaani, and there was, let's say, 10 million tons of tailings which Otamäki mine acquired, and then they decided that they will do some raw materials for cosmetic and paint industry from those, and they have had a very clever and good cooperation with the GTK, Geological Survey of Finland, about this, and there is now solutions how they can make some very pure titanium dioxide from those tailings, and also getting quite many other pipe products same time which are commercial. So it's looking very promising that about the total closure of that mining history. So it's might be interesting to check also in investor eyes that what is happening with Otamäki in future. So then it's of course Tapojärvi is the legend in Finland that they have been long time in a circular economy, and the company started 50 years ago, and they have been many decades working together with Outokumpu stainless steel plant, and they are recycling a lot of the steelwork slag, and one of the solution is how to collect the calcium hydroxide from the slag waste and recycle it and replace pure calcium hydroxide, and similar solutions have been used also in Italy, and now the slag waste in Italy is under end of waste status, so it's Terna stainless steel production is going also to same raw material area, and basically that is Tapojärvi is also doing a lot of work within tailings with many mines at the moment. Then some water treatment specialists, that there is 3 which are startups all, and but they have quite clever ideas how to collect some very highly selected metals from waters. That there is especially Ovatec have mobile solutions that so they can basically sell the sea container size units to all over the world, and it's a very easy to install process, just pipe in and pipe out, and it is collecting quite many different kind of minerals and metals that it can be modified for many different kind of the tailings and liquids. Then let's say EPSE have a lot of activities globally going on, that quite a new player in the water treatment area, but a very unique way how to collect all of metals, and that way that then that can be used in concentrators or smelters as a raw material. So it's let's say EPSE have done a huge amount of great work with many of mining companies in Finland, and also now in globally that they are actively with mining Indaba and BDAC and all the other events. So it's then MacShort is also that it is recovering metals from slags, and also quite easy to install solution, that it's like a very small unit to add to almost whatever kind of production plants. Then a little bit about Finnish way, how we are doing in business in Finland. That it is like of course there is a lot of challenges, that there is basically we are facing all of similar challenges globally than all the rest, but there is, let's say, together we have solved quite a lot of different kind of solutions, but we put some points that which kind of challenges we need to tackle in future. And there is like one is of course that how we can use more side stones in urban construction, and there is a lot of solutions coming on together with those earlier startup companies, that they are solving some metal challenges in those side stones, and same time it could be used in construction industry. Then new innovators are needed, and it is of course great to see that how much of innovative companies there is also in this room at the moment, and then there is, let's say, of course. Funding is one issue, that there's a huge amount of innovations, but how to get those to commercial level, that there is of course good that there is also investors teams in here that we can discuss more about those possibilities, and also more public-private R&D to support is needed. Then it's a little bit what is this Finnish cooperation that I'm proud to be part of that team, that it is quite unique that there is so active cooperation between companies, research centers, universities, government, and share the same goal and discussing that how we can solve our main challenges and how we can also help with our technology solutions globally and especially in developing countries. And we have been traveling a lot in many developing countries and discussing about Finnish sustainability technologies. That it's of course there will be also one innovation competition together with EIT raw materials in the next year. That we are looking for best startups from Europe for that mining innovations. That there will be 5 topics in that that will be together with government and many research centers. But there's of course like more than 10 mining-related universities in Finland and many research organizations, over 200 mining technology providers, and then also service providers, over 40 mines, totally 10 smelters and steel mills. So it's quite a big group of, I didn't put battery production, but there is of course a lot of battery projects going on also in Finland now, that it is covering quite well value chain of mining, and we are trying to do cooperation a lot together and learn at the same time how we can grow together to be ready in global markets. But thank you very much for being here, and if you have any questions that there is some, let's say, possibilities to connect, that there is, of course, feel free to send me email, whatever kind of questions you have about mining technologies from Finland or some services. And also feel free to check our new brochure that we were lucky that in 2 weeks 55,000 people have watched our new brochure, that there is information about 78 companies and 78 members and 40 companies who are doing cooperation with us, and quite a lot of basic info what is happening in mining in Finland. So it's and also in LinkedIn we have about 7,000 followers, so feel free to watch what we are doing in Finland. But it is of course once again that great to see so many talented people here, so it's proud to be in this team. So let's solve mining challenges together in global scale.
Thank you, Lasse. That was very interesting. It's a bit eye-opening, 76% of waste from mining, and good to see that you're finding some reuse for that. I think we've got time for one quick question from the floor, if anybody has anything they want to ask. No questions today. Could you just tell me a little bit more about the innovation competition that you mentioned just there at the end?
Yeah, we are looking now 5 sponsors to this competition from Europe. That basically the idea is to find the 5 companies who have some bottlenecks in some part of mining, and we will start this innovation together with EIT raw materials after a few weeks. That we are just launching the process, and soon there will be more info about that in our webpage. But the idea is to find the best innovative company in mining from Europe, and that will be published in a material exhibition, which will be the biggest fair of next year in Finland. So it is about exactly 1 year from the 6th and 7th of November next year.
Good stuff. Good opportunity for somebody there. Thank you very much. Thank you. Okay, I'd just like to welcome our last speaker to the floor, Małgorzata
Szumska, I'm sorry.
I'm sorry, no, my apologies. And I'm a little bit disappointed I'm going to miss the tour tomorrow, but obviously going to tell us more about the mine tour, about the mine itself, and obviously where some of us are going to visit tomorrow.
Yeah, hi everyone, I'm Małgorzata Szumska, which is hard, so you can call me Meg on a tea break. And I'm CEO of the gold mine, which I think sounds awesome, but I'm not from the mining industry. I'm from the post-mining industry, which is tourism in my case. And let's face it, every mine will be closed at some point. People will lose the job. The environment will be a bit or more or less destroyed. And what happened then? Then, if you're lucky, you will have mom, as I had, and someone will make beautiful attraction in that place. And I want to tell you about the passion and about story of my family. So let's see. Yes. Where are we? We are 2 hours from Wrocław, is 70 kilometers, but road is really bumpy, so it takes 2 hours. And I know some of you will visit us tomorrow in a gold mine. There are a few more places in a bus, so you can still join. And we are close. There's a red spot next to the Czech Republic. This year we have 750th anniversary of our mine. It all started in 1273. And now, very briefly, because there's like lots of stories about our mine. In 1973, they started looking for gold in Złoty Stok, which is tiny, tiny town. In 1575, the Fugger family, very wealthy, very famous family of bankers, they had in a pocket like every king in Europe. They were even sponsor of Christopher Columbus, who was supposed to find a way to India, and he discovered America. And they sponsor Christopher Columbus with the gold from our gold mine. But in 1565, there was a big disaster underground. 59 miners went down and the mine collapsed. No one ever reached for them. No one ever rescued them. They stayed there forever. This is important. Why? I will tell you at the end of my story, so no one will leave, hopefully, this place. In 1612, for the first time in the whole world, the black powder was used underground. It was in our mine. In 1709, they find out there's not only the gold, there is arsenic. So for the 100 years, we were only one producer in the whole world of arsenic. 19th century, we were lucky with a Gittler family. Lower Silesia, where we are now, where is Wrocław, where is mine, Złoty Stok. It was a German area till Second War. So the Gittler family, German family, took care of our town, of the gold mine. That was the golden era for Złoty Stok till Second War. In 1945, Lower Silesia come to Polish hands. The Polish people tried to look for gold there, look for arsenic, till 1961. In 1961, the gold mine was closed. And it's funny, because our mom was born the same year. In 1996, few investors from Poland and local government decided to open few kilometers for public, for tourism. They thought, like, this is the gold mine. Everyone wants to see the gold mine, so obviously we will have lots of tourists. But after a few years, they realize no one knows about the gold mine, no one is coming, and the attraction doesn't bring any money. So they were looking, I'm sorry for the word, but they were looking for loser, someone who will buy the shares. And our mom was first in the line. She was like, I want to buy it. I'm ready to have a gold mine. She was my age that time, and she was a farmer's wife, so it wasn't that easy to have money to buy the gold mine. So she went to the bank and said, like, hi, hello, I would like to buy the gold mine. You can imagine the faces of the old people working in the bank, like no one actually knew there is any gold mine there. So she was walking from bank to bank. She visited 7 different banks. Finally, one of the directors said, like, okay, tell me more. And she got the loan, but she needed to secure it. I was 10 that time. That was like really dark era for me. My mom needed to secure the loan with something. So she put everything on one card. She put the house, all the fields we were farmers, the car, even the cow. So it was like black and white situation. Or we will win, or we will lose everything. So from the very beginning, we knew, we as kids, my sister is here as well, we knew we need to work hard in a mine. Like you can imagine my childhood. We have to work hard to just take care of the business family. My first job, I was 10, it was being a dwarf. And I was running underground and making tourists scared. And now I'm CEO, so it's kind of story like from zero to hero. So hopefully it's inspiring. This is our mom. She started this with passion. Even when she didn't work, before they opened the gold mine, she was going there underground when it wasn't open. She was just exploring. We had 300 kilometers of mines in Złoty Stok. Our mom discovered 30 kilometers, just 10 persons. So there is still lots of things to do for us. From the beginning, we had 3 rules how we want to run this company. First of all, we were investing imagination because it's fun and because we didn't have money, because we spent everything to buy the gold mine. So like, it's hard to invest money when you don't have it. So from the beginning, we knew we want to make beautiful, magical place. We were talking with my family, with my sister, with my mom, like what kind of legend we can make, what kind of history we want to serve people, how we want to entertain them, how we want people to be back. But from the beginning, we know we want to make a space which is friendly to everyone. So we left parking free, toilets free, we have free attractions, free playgrounds, free picnic spaces, so people just pay only for the attraction, but they can spend with us the whole day. And we wanted them to be back, because it's harder, I guess, to reach new people. It's always better to get the same people and just make them coming back. So our rule is open something new every year. Every year we're doing some small investing. We renovate, we open new attraction. So people, when they're coming back to our gold mine, they know there will be something new. We started with 3 workers and 1 dwarf, and we 300 tourists per year. Now we have 300,000 visitors every year. We hire 140 people, which makes us the biggest company in our small region and the biggest private attraction, tourism attraction in the whole country. You can spend the whole day, tomorrow we'll see, you can spend the whole day with us. But it's not only about the business, it's a big responsibility when you're taking care a place like that, with the heritage, with the culture, with the hard history of Polish, Czech, German people living on that land. So from the beginning, we knew we need to take care of it. We are responsible for it. We're doing lots of projects to make local people be part of our, not business, but the project. It's, first of all, it's us having a passion. There is our workers who feel like they're part of it. They're not just working for us. They're really proud of the place we all building. But then it's the rest of the community, the town, which is full of people who doesn't have any place to work, who don't believe yet in tourism. So it's our mission to just make them believe, like tourism, it's a good direction for everyone. From the projects we are doing, it's not only about mining, it's about the whole history. It's, for example, 10 years ago, another anniversary, we opened a museum, which is public free, there is no fee entrance, and every person from our area can bring something they have, something, some souvenirs, some exhibit, and they can donate it. After some time, we see like people donate something to our museum and they coming back with their families, so proud, like they are part of that project. So I think the mission is like not only run the business, just build the new community in the post-mining area. One of our biggest projects was to find Ochrowa Adit. This is the mine from 16th century. It was all made by hands with 2 tools. Day by day, few centimeters per every day. We were looking for that mine for years, spending time in archives, walking on the field with old maps, like 200-300 years old map, and we were looking, where is it? Finally, we found the place, we started digging, and we opened it. We found inside a wooden pump from 16th century, which were working. I think it's only one pump like that in the whole Europe, and it's just the wooden thing, and it's not really excited if you don't know what's that, but for us it's like huge treasure. And now all the tourists can walk in that adit by themselves. We love missions like that, and I'm telling about this because, first of all, if you will have project like that, if you will see people who really want to do something in post-mining area, and they have a passion, only what they need, it's not even the big help, they just don't need to be disturbed. Just let those people follow their passion, and obviously they'll do something amazing. We have few big projects, and I'm really happy I can say that in front of such a smart people from mining industry, because our dream is to reach these 59 miners I mentioned at the beginning. They were stuck 400, 500 years ago underground. Now what we are doing, we're looking for this mine which disappeared 500 years ago. We have only one map. The map is 200 years old, so it's not an easy thing. If you know any, I don't know, any technology which can help us, if you can give us any advice, I will be more than happy, because all we did is just walking around the forest with this old map and like thinking, maybe it's here, maybe it's there, maybe it's somewhere. I think it's kind of like playing Indiana Jones adventure. So if you want to be part of it or just help us with any advice, I will be more than happy. And we're not stopping. We will keep doing, keep taking of the heritage, keeping, having an eye on our culture and still developing. So, it's a great mission, it's a great passion, as you can see. I speak really fast because I'm so excited. And I really hope you like our story. I really hope I can inspire you to love the mine, and even if it's not working anymore, even if it's closed. Like post-mining area can be beautiful, and it can bring joy to lots of people. Thank you very much.
Małgorzata, that was amazing. I love your passion, and I want to come to your mine. I'm going to change my flight for tomorrow now. Please do. That was brilliant. Has anybody got any questions for Małgorzata, or somebody who might know how they can help find the...
A comment as a mother, how happy your mother should be to have such a daughter. Oh my God, amazing.
Actually, it's three of us. Thank you. It's three of us. It's me, my sister, and our brother. And Mom is happy. No one is asking if we are happy. She just kept us in the mind the whole childhood, and we didn't have choice. But yes, the family is happy. Thank you.
Yes, all three wonderful children. Congratulations to your wonderful mom.
Thank you. Can I just sneak in one quick question? I just wanted to ask you, like, what was the hardest thing when you were developing this mine? What would you say is the hardest thing?
Obviously, the hardest thing for us, it was to make people believe like such a small, unknown mine can be famous, can be fun, can be the place you want to visit. Like Laue Silesia is full of tourist attractions, so it was really hard for us to just like stand there and say like, hey, we are here, please visit us. People already knew where to go because the older attractions were more known. So for us, advertising was hard, but we had so many good people helping us. And I think it's maybe because of the passion. Like once someone visited us, they wanted to help us, and they brought more people. And then we met some journalist, and she said like, "Oh, I will write something for free about you." And like, you know, like if you are like good and you have good energy, I think you just attract good people. So we were really lucky with that business. But yeah, the hardest thing it was like show up and say like, "Hey, we are here. Please visit us."
Amazing. Thanks again. Appreciate
Thank you very much.
Thank you. Okay, and I think we're 5 minutes over for the coffee break, so again, thank you to all of our speakers today. Thanks very much to you guys.